So in this section, we're going to start talking about properties of functions. Specifically, we want to be able to look at the graph of a function and determine where the function is increasing, decreasing, or constant. We also want to be able to look at a graph and identify points that are local extrema, which means local minimum, local maximum points, and also find the absolute minimum and the absolute maximum for the graph. So I'm going to begin with an example where we're going to look specifically at the increasing, decreasing, and constant intervals of the graph. Now, when you read a graph, you're going to read that graph from left to right, just like you would read text in a book. So most students do not have trouble identifying a place on the graph and calling it an increasing or a decreasing or a constant interval. For example, if I start on the leftmost point and I trace my graph, we can see that because the graph moves up, we would call that an increasing section of the graph. Now, what tends to be an issue is how we write that increasing section of the graph. You want to remember that when you are writing increasing, decreasing, and constant sections, the intervals that you write need to be in terms of the x only. So for the section that I've highlighted on the graph, we're going to look at the x value where it starts, which is going to be -7, and then the shading or the highlighting stops at an x value of -6. And so I would write that interval -7, -6. Let's look for another place on the graph where it's increasing. So we could say that the graph is also increasing on this section. And so that section of the graph, the increasing, begins at an x value of -2 and ends at an x value of 0. And then the graph is also increasing here. And so the increasing begins at an x value of 2 and ends at an x value of 5. All right, what about places where the graph is decreasing? So the graph appears to be going down on this section. So this section begins with an x value of -6 and decreases until we get to -4. The graph also decreases here, which begins at an x value of 0 and ends at an x value of 2. And then finally the graph decreases here, which begins at an x value of 5 and increases all the way to positive infinity. In terms of constant sections, we're looking for a place where the graph is flat. In other words, it doesn't go up and it doesn't go down. So our constant section of the graph would be here. That begins at -4 and ends at -2. So again, the important thing to remember is that when you're writing the intervals for increasing, decreasing, and constant, remember that you are writing them in terms of the x. On our next example, we're going to take a look at finding the local minimums and the local maximums, and also the absolute minimum and the absolute maximum. So we've already talked in class a little bit about what makes a minimum or a maximum. Remember that a minimum is going to, a maximum is going to have this behavior where we're talking about a top point. So on a maximum, on the left side, you're going to be increasing, and on the right side, you're going to be decreasing. If on the left side you're decreasing and on the right side you're increasing, then you have a bottom point, which is we're going to refer to as a minimum. So we can pretty easily identify that type of behavior by looking at our graph. For example, this point, because the graph goes up on the left and down on the right, we can say that that has a maximum type behavior. Because it's not the maximum point on the graph, we're going to call it a local maximum. And what that means is just when we look at the behavior of what's happening to the left and to the right, we have that behavior where we have a top point, even though it may not be the top point on the graph. All right, we're also going to have another local maximum over here. Again, if we look at what's happening right around that point, it's going up and then it's going down on the other side. And so that will also be considered a local maximum. So you want to keep in mind when you're talking about local minimums or maximums, you can very easily have more than one on a graph. Sometimes these are written just in terms of the y values. We're going to go ahead and just use the point. So negative 2, 2 will be a local max, and 4, 2 will also be a local max. Okay. Now, it's probably worth noting that this point is not considered to be a local max because in order for it to be a local max, you have to be able to say that it's increasing on one side and decreasing on the other. And we know that it's decreasing over here, but we don't know what's happening on this side. All right, so let's think about local minimums on the graph. So we would have a local minimum here. We see that the graph is coming down on one side and going up on the other. We would also have a local minimum here. Again, graph is going down and then graph is going up. So again, sometimes these are written just in terms of the y's, but we're going to use the point. So we'll say negative 4, negative 1, and 1, 0 are local minimums. And again, this point is not considered to be a local minimum because local minimums have to come down on one side and go up on the other, and we don't actually know what's happening on the right-hand side there. Okay, so that takes care of the local mins and the local maxes. All right, let's talk now about the absolute minimum and the absolute maximum. So by definition, the absolute, I'm just going to jot this down, the absolute maximum is going to be the highest point in the domain of the function. And likewise, the absolute minimum it's going to be the lowest point in the domain. So what that means is that you are looking on your absolutes, you are looking for the highest point on the graph. Regardless of whether we can actually call it a mountaintop like a maximum, you are looking for the highest point on the graph. And so the highest point on the graph will be this one. That point is higher than anything else, and so this will be our absolute maximum. For our absolute minimum, we are looking for the lowest point on the graph, which would be this point. So this would be our absolute minimum. Okay, and again, sometimes those are written just in terms of the of the y, but for our purposes, we're going to go ahead and write it in terms of the point. So my absolute max would be the point -6, +4. My absolute minimum would be the point 5, -2.